disjoint and overlapping probabilities today. First of all, we have a compound events. So that word compound, you need to underline it if it's not already underlined or highlighted on your paper. Compound. So a compound event is when you got two or more probabilities happening at the same time. Okay? The way we find the probability of a compound event is we add them together, and it'll say the word or. So or means we add. You might want to write this on your notes. It will help you on your quiz. Or means to add. So if you say or for a probability, you want to add them. You're going to add the two probabilities. So remember on our notes the other day, we listed out all the different types of, please put that away. Our notes from Friday, we listed out all the different kinds of cards that we have. A playing card, we have 52 cards in a regular deck of cards. There's 4 different suits. There's 13 cards in every suit, right? And we got an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, king, queen, and king, right? In every deck of cards. We got hearts, clubs, spades, and diamonds. Half are red, half are black. So we talked about cards on Friday. And so we've got a standard deck of 52 cards. That's supposed to be cards, not cars. Fix my writing, please, because I know I have a typo there. That should say cards.
Frank can need to come to the office. He's checking out.
Okay. So you'll need to fill in your notes tomorrow because you still have a quiz on Wednesday. Okay? All right. What is the probability that a card is a 10 or a face card? Remember we talked about face cards the other day. Those are jacks, queens, and kings. Okay. Okay. So if this says or, that means we're going to add the two probabilities. Find the probability that a card is a 10 or a face card.
So 4 times 4.
No. So how many cards in a deck of cards are 10s?
4.
There's 4 10s out of how many? 4 of them out of 52 are 10s. So that's the probability I get a 10. Okay? Or a face card. Now, I've got a face card is a jack, a queen, or a king.
What about the ace?
That's not a face card. Ace don't have a face. Right? I showed y'all that. Ace don't have a face. You were. Okay. Here's an ace. It don't have a face. Right? Here's the queen. She got a face. Right? So when they say face cards, they're talking about jacks, queens, and kings because they have faces. All right. So I've got jacks, queens, and kings, but I got them for all 4 suits. Right? Right? So how many total face cards are there? Well, there's 4 suits. So there's 3 of them
12.
times 4. So there's 12 out of 52 face cards. Y'all agree? So of diamonds, I got a jack, queen, and king. Hearts, I got a jack, queen, and king. For spades, I got a jack, queen, and king.
I said 4 times 4, and that would have been right. It would have been 16 over 52.
That's for something different, sweetheart. This is, okay, you got to have the probability of getting a 10 and the probability of getting a face card, and you add them together. So you said that at the beginning?
So it would be 16.
This.
That's what I said.
Good. And then you reduce that. And these are both divisible by 4. So 16 divided by 4 is 4. 52 divided by 4 is 13. So 4 13ths. So or means you add them. Or means you add. All right. What is the probability that the card is an even number card or a red queen? An even number card or a red queen. So let's first find the probability that you get an even number card. Well, what cards in a deck are even?
Oh, the numbers went.
2, 4, 6, 8, and 10. Right? There's 5 of those times 4 suits is how many of them?
4.
20. There's 20 of them, right? So 20 even number cards out of 52 for the even number card. Is everybody okay with that? Plus, how many red queens are in the whole deck? 2 red queens out of 52. And then we got a common denominator of 52, so we add across. 20 plus 2 is 22 out of 52. And then we'll reduce that fraction. We can divide them both by 2, can't we? What's 22 divided by 2? 11. What's 52 divided by 2? 26. So the probability that we get an even number card or a red queen is 11 out of 26. Does that make sense? Okay. So let's talk about dice. Actually, we're going to talk about one die. Yeah. Don't say anything incriminating. Okay, so I got one. So y'all know that one's a die, 2 are dice, right? Right? One's a die, 2 are dice. I dropped it. Smooth move, X-Lex, right? Okay, so what numbers are on a die?
1 through 6.
1, 2, 3, 4, 5, 6. What's the probability that a number is less than 3 or a 6? Well, how many numbers on a die are less than 3?
1 and 2.
1 and 2. 3 is not less than 3, is it? So 2 out of how many?
6.
6.
1 over 1.
Plus, how many 6s are on a die?
1.
1 out of 6.
That's 3 over 6.
3 over 6. And then that's a half. So the probability that I roll a number that's less than a 3 or a 6 is a half. Got a 50-50 shot. Next one, what's the probability of rolling a number that is a 2 or a number greater than 3? Well, how many 2s are on a die?
2.
How many 2s are on a die?
Oh, 1.
There's just 1. So 1 out of 6 to get a 2. How many numbers are greater than 3?
3.
A 4, a 5, and a 6. So 3 out of 6 probability of getting a number greater than a 3. And then I add them together. 1 out of 6 plus 3 over 6 is 4 out of 6, which is 2/3. Very good. Okay, so any questions on, they call those just disjoint compound probabilities. Now let's talk about overlapping probabilities. Now, an overlapping probability is when something can happen in more than one category. Like, say, what's the probability of rolling a 2 or an even number? Right? Well, 2 is an even number, right? So what you have to do is you do it like it's a regular or, you add the 2 probabilities. Then you go back and subtract the probability of rolling what goes in both categories or what happens in both categories. Okay? So if they happen to happen in both categories, you have to subtract that probability. Okay, so let's talk about cards again. Find the probability of drawing a card that is a black card or a queen. So first, let's find the probability of getting a black card. How many black cards are in a deck?
50% of 52, which is 26.
26 of them, right? Half a deck is black, half of it's red. So that's going to be 26 out of 52. Plus, what's the probability that there's a queen in a deck?
4.
4 out of what?
52.
4 out of 52. So there's 4 queens, right? But are there any queens that are also black?
Yes.
Yes. How many?
2 of them.
2. So I have counted the probability of getting a black queen twice, right? Because it's included right here and it's included right here. So I need to subtract those away. So how many black queens are in a deck?
4, but you only.
No, how many black queens?
2.
There's 2 red queens, 2 black queens, right? So I subtract 2 out of 52. Does that make sense? So anything that's in both categories, you have to subtract off their probability. So 26 plus 4 is 30. 30 minus 2 is 28 out of 52. And then those are both divisible by 4. So that's what, 7 out of 13? Math inner is your friend if you can't reduce your fractions. Any questions so far? So that's what you do if it's overlapping, meaning it falls in both categories. All right, now we're ready to flip over to the back. What is the probability of drawing a card that is a spade or an ace? Well, how many spade cards are in a deck of cards? 13, right? A fourth of the deck. 13 of them. So, yeah, we ain't count jokers. Yeah. They say a standard deck is talking about the main 52 cards. So 13 out of 52 are a spade. How many cards in a deck are an ace? 4. Could you be a spade and an ace?
Yeah.
Yes. How many ace of spades are there in a deck? 1. Right? So I subtract the probability of getting an ace of spades. Does that make sense? So I don't count that one twice. So 13 plus 4, 17 minus 1 is what? 16 out of 52. And reduce that fraction, divide them both by 4.
13.
So 4 over 13. Any questions about those? All right. Next one. What is the probability of rolling a number that is an even number or a prime number? So let's talk about it. We're talking about a die again.
The thing about those, though, I learned if the dice with the corners are round, you will roll more of the either. If the squares are more of the
I've never tested that theory. I'm getting even and odds. Yeah, I'm not on a flat surface either. But anyways. Yeah, this one's rounded, but I've got some squared off corners too. All right, so if I'm rolling a die, what's the probability that I roll an even number or a prime number? So here's our numbers on a die. 1, 2, let me write it down here. 1, 2, 3, 4, 5, or 6. We'll do them in order. Even number first. So how many even numbers are on a die?
3.
2, 4, 6, right? So 3 out of 6 are even. Plus, how many numbers are prime? Well, prime numbers mean the only numbers that go into them are 1 in themselves, right? So, is 1 prime?
Yep.
Is 2 prime?
Mm-hmm.
Is 3?
Yep.
Is 4? No. Is 5? Yes. Is 6? No. So, how many numbers? Yes, 4 out on a die, 4 out of 6 on a die are prime. Now, are there any numbers that are even and prime? What number is even and prime? 2. So what's the probability I get a 2? 1 out of 6. So I have to take that away. Anything that overlaps after you add, you subtract that part off. Does that make sense? Because we don't want to count it twice. So 3 plus 4, 7 minus 1 is, that's supposed to be out of 6, not 2. 3 plus 4, 7 minus 1 is 6. 6 out of 6, which is what? 1. What does that mean to have a probability of 1?
10%.
10%?
No.
It's 100%. That means it's going to happen, right? No matter what I roll, it's going to be either an even number or it's going to be a prime number. Let's try it out. I got a 3. Is it even or prime?
Yeah.
It's prime. I got a 4. Is it even or prime? It's even. I got a 5. Is that even or prime?
I rolled.
Think about it, Lee. There's only 6 of them.
I used to shoot dice in jail. So what I gotta do?
Just roll it. Tell me what you get.
Right there.
Anywhere.
Okay.
What number is it?
Oh.
Is 4 even or prime?
Even and even.
It's even.
3 prime.
3's prime.
But what I gotta do then?
Keep rolling.
You can't win.
This is fun.
I just do
What'd you get?
3.
double up there. Told you. I'm
It's
good.
3. And guess what? 3's prime. Guess
so I gotta
what?
roll a what? 4 or 6?
They're even.
They're evens.
But you said, what's the whole point of this?
We're saying the probability is 1. That means no matter what I roll, it has to be even or prime. Probability of 1 means you got 100.
I think I got 2 dice.
You
You
never-
roll a 7.
This
I
is
got
fun.
6 dice. Now you take a 7 or 11 or 9. I gotta put down.
Yeah, exactly. This is just 1. All right. So yeah, it's not going to be a probability of 1 if you have 2 dice going on, right? Because like there's going to be more that are not even and prime than just
You
yeah.
got twice the number.
Exactly. So a probability of 1 means 100%. It's going to happen. Okay? So if you get something that's a probability of 1, that means it's always going to happen. All right. That was fun. Thank you for the entertainment. All right. So this, I really didn't have to type this out for you guys because it's not much words to it. It's just math. It says events A and B are disjoint. That means they have nothing to do with each other. There's no overlap. Find the probability of A or B. So I told you when you see or, you're going to do what? Add the probabilities. So probability of event A is 0.3, event B is 2.5. So the probability of A or B, you're going to add them. 0.3 plus 0.25. And what does that equal?
55.55.
0.55. Right? So a little bit over a half. So probability of A is a half. Probability of event B is 2/5. What's the probability of event A or B? What would you do? You would add a half plus 2/5. We need a common denominator for that, don't we?
Yep.
What's the least common denominator between 2 and 5? 10. So a half is 5 out of 10. 2/5 is, well, what times 5 is 10? 2. And 2 times 2 is 4. So that's what? 9 out of 10. Right? So on your homework, when you have problems like this, you just add the probabilities. If it says they're disjoint.
Should we not just make the decimal and then do math?
Not in Algebra 2. They give you fractions, give me fractions. If they give you decimals, give me decimals. Okay. Okay. All right. The last part, I have it written on your notes, but I don't have it written on mine yet. And that is talking about the word complements. Now, we said the probability equaling 1 means complete, 100%. Right? So the complement is going to be 1 minus the probability. 1 minus your probability. So if you want to find something's complement, you're finding what combines with it to make a probability of 1. Okay? So finding something's complement is finding what it takes to go with that number to make 1. So, for example, find the complement of A, the little bar means a complement, when the probability of A is 0.6. Well, to find the complement, which is P of A bar, you're going to say 1 minus 0.6. And what is 1 minus 0.6?
Negative point.
It ain't a negative. It's just
Yeah.
0.4. 0.4. So that means if I have something that has a 0.6 probability, I need something with a 0.4 probability to go with it to make 100%. Does that make sense? So when you're finding the complement, that's what you're finding. What goes with that number to make 1? Okay, let me get one more space up here. And here's your other example. Find the complement of A when the probability of A equals 3/5. Of course, I gave you a fraction. Okay, so to find the complement, you're going to say 1 minus 3/5. Well, common denominators help a little bit. 1 is the same thing as what over 5? 5 over 5. So 5 over 5 minus 3 over 5 equals what? 2/5. That's all you got to do. Is that terrible? Really not. That's like 4th grade math right there with those common denominators. All right, so that is the end of section 10.4. Have a good day.